Um, hey guys, just had a quick chat with Fred, the production manager. And to be honest with you, what I found out was that he's a very smart and hardworking person at site, and he's got a full understanding of rule number one when he wanted to mark the notes for the hazard and operability study, HAZOP study. And it was perfectly clear for him when there is a phase change, a new node starts. Well, that was the first rule that we've discussed about that in the previous session. What I found out was that he was a little bit uncomfortable about where to stop the node, not where to start it. So it was quite clear for him where to start it, but not where to stop it. So um, at this point, actually, he was feeling a little bit um, uncomfortable, and he was just asking questions from himself. Is he doing the right thing, or is it possible that he might be missing any of those hazards because of not identifying the correct nodes? So basically, at this point, usually people go under the pressure asking themselves these kind of questions, and that is because uh, losing or missing a point is not just a technical matter. It's more like losing credibility, and more likely it's just like uh, even leading to losing lives of people. So he was aware about my website www.mohammedjpgolshani.com has an academy. So jumped on that website, and he booked a 15-minute free consultation with me. And he was just asking this question that I'm fully aware of rule number one, but I would like to learn more about where to stop the node. And that's basically confusing me because sometimes it's straightforward, that's all right, but sometimes it's not as straightforward as I thought it would. And then I need to get back and see how I can sort it out and stuff like that. Anyway, I saw that 15 minutes of consultation is not too long. Therefore, I decided to actually coach him rather than to teach him. So I started asking the questions from the scratch to see if he's done his own work. And so, yeah, as I said, I asked Fred that what's going on in the process. And you know that we don't just jump into marking nodes, and we need to do our own homework. So, what have you done? So he explained to me that he has gone first through process description document, and he's quite familiar with what's happening in the process. And even he has read completely the functional description as well as the control philosophy, some documents regarding the cause and effects and how the controls are taking care of the process, and how the safety system potentially are tripping the system whenever it's required. And then he started telling me more about the process. And well, I'm going to explain the same thing for you guys before I jump into explaining rule number two. It seems like that the process we are looking at is a fractionation column called T101, where benzene and toluene mixture is introduced from the left hand side through a 3-inch Schedule 40 carbon steel pipe into the fractionation column, where it's being separated into two different phases. One phase is more volatile, which is the benzene side, and the other one is the less volatile material, which is the toluene side. And then as it passes through the fractionation column T101, it then separates into two different streams. One is pure benzene, which goes out from this fractionation column ultimately via a 2-inch Schedule 40 carbon steel pipe, and then the other stream is toluene, which is another product which is being separated by this fractionation column. So the next question I asked him was that walk me through the process and tell me what you understood from the process. So he said that on the left hand side a mixture of toluene and benzene are being introduced into the fractionation column or the distillation column. So T101 or Tower 101, and then it, as soon as it enters into the distillation column, it is separated into two different phases. One is the liquid and the heavy or less volatile material, as I said, toluene, and the other one, which is the benzene, which goes to the top of the column, which forms the vapor phase. And the energy which is required for this process is actually provided through exchanger 106, which is the heat exchanger 106. It's a shell and tube. It's got medium steam passing through and delivering heat and boiling the mixture of benzene and toluene, and then separates them based on the boiling points. So the energy is supplied via this heat exchanger, and actually this is the driving force based on which the whole process of separation is occurring. And yeah, that's the steam line, which I'm showing it now at the moment on the PNID. And then you see that on the same PNID, the amount of the steam or the energy which is required for the separation process is actually controlled via a temperature control valve, or a TCV, which is already receiving a signal from a logic solver, temperature controller, and a couple of elements which are already located in different locations of the fractionation column. Then we go to the top of the column where the more volatile material, which is the benzene, is separated at the top in vapor form, passes through from the top of the column to exchanger 104, which is a condenser. So this exchanger is basically receiving cold water and is actually condensing vapor benzene into liquid benzene, which ultimately gets collected in V104, which is a vessel. And as soon as it gets into the vessel, it separates into two different phases of liquid at the bottom and the vapor at top. Both of them are benzene, but liquid is at the bottom. And then the vapors and the lights are actually passing through the top of the V104 into the fuel gas stream, and is being burnt there. So these are the light materials which are being separated from the pure benzene, and it could be some vapors from the benzene itself, but in a very low composition. The whole process here is being controlled by a pressure control valve, which is connected to a pressure element and a logic solver, which is controlling the whole back pressure, how much of this gas will actually go into the fuel gas system. And then we've got this midstream or liquid phase, which is at the bottom of the V104. It's pure benzene, and it's being transferred downstream to the storage area via a 2-inch Schedule 40 carbon steel pipe. As you see, the level of the benzene liquid in V104 is being controlled by a level control valve connected to a level transmitter and a level element, all of them being fed into a logic solver, and a level controller, which is looking into the level of the vessel and letting the streams go into the storage area, controlling it. The liquid inside V104 is actually divided into two different streams. One stream goes as a reflux flow back into the fractionation column to improve the quality of the fractionation, and the other part is actually leaving the fractionation section via another stream directly to the storage area. As we see that the whole process in the liquid benzene side is being controlled by a level control valve, and the reflux is being controlled by a flow control valve connected to a flow transmitter and a logic solver and a flow element, which is measuring the amount of the reflux flow which is required in the column. Then he started explaining that the liquid side is toluene, which is at the bottom of the column, and basically it's being controlled by the level of the liquid at the bottom of the column. So you got level elements, which is feeding into the level transmitter and into a level indicator and the controller and a logic solver, controlling the level of the liquid via LCV, a level control valve, and then the toluene is being actually routed out from this PNID into the storage area. So basically that was what Fred explained to me regarding the process which is happening there. As I told you, he's got a 360-degree view, fully confident about the process, the control side, and then he wanted me to help him to identify the node. I noticed that one of the points in this short 15 minutes consultation I can actually pass him is that the liquid side is just, sweet as, just do the node identification as per what we've discussed on rule 1. Therefore, first thing I just wanted to check how confident he is to mark node 1, which is the bottom of the column, where the toluene is being separated and goes out from the right hand side of the P90. So he just told me that, well, we've got rule number 1, which says every phase change means a new node. Therefore he marked the whole thing, the bottom of the column and the stream, routed from that to the end to the right side, as has been shown here on this PNID as node number 1. And then I brought to his attention that we together are going to go and I'm just going to coach him how to identify the node number 2 and node number 3 accordingly. Right. At this point, I started introducing rule number 2 to Fred, and I told him that what does rule number 2 says? It says, do not extend the node further than 2 or 3 related equipment. And it sounded a little bit strange for Fred right at the beginning, but I just told him to keep that in mind, and we'll go through marking node number 2, and you'll notice that in a better way. So we started node number 2 from the left stream that entered to the column, fractionation column of benzene and toluene. And as we said, it's separated into 2 different phases. It was quite easy for Fred to mark the vapor phase as well on the top of the column. So the vapor phase just got out from the top of the column. It went into the condenser E104, as we've discussed about that before, by using cold water the temperature of the vapor was dropped, and the whole fluid flashed in vessel 104, V104, and it changed the phase into two different things. One was the liquid phase, and one again a vapor phase. So here was the point about rule number two. Fred counted, and it was two equipment um, down from T101, which was exchanger 104 and V104. So I was just asking him, so should I go further than that? Then he remembered it says 2 or 3. So he thought that here we have a reference to rule number 1 as well. Should I start a new node at V104, or because the vapor phase which was coming out from T101 still is in V104 partially? Should I carry on the same thing? So he just kept marking that as node number 2, which I believe was a correct thing, because we can consider the PCV pressure control valve as another equipment which is in the system. So it was basically 1, 2, 3. It was E104, V104, and the PCV, which is controlling the pressure at top of the column. So he carried on and marked the whole thing with a blue color at node number 2, and I believe he did the right thing. And rather than I mark the node and explain it to him, I let him know the rule number 2, and he by himself actually did a little bit of work, and had all those thoughts and doubts in his mind, and finally made his decision, and he extended the node up to the top right corner of the PNID, where the line is going to fuel gas, and marked the whole thing as node number 2. And that was when I asked him, okay, it's time to mark node number 3, and I believe he just jumped into doing that in just blink of an eye, because it was quite easy for him to understand that there was a rule number 1 which talked about the phase change, and he noticed that now at the bottom of V104 we've got a new phase, which is the liquid phase, and he just marked the bottom of V104 as new node 3, and he noticed that the flow coming out from the bottom of V104 is split into two different streams. One is going back as the reflux stream into the top of the column to increase the quality of the distillation, and the whole process on the left hand side on the reflux is being controlled by a flow control valve. And then he counted, and apparently it was just a single equipment down from that stream. So he was quite comfortable marking that as node number 3. And then on the right hand side, he noticed that the majority of that liquid phase is actually being pumped to the storage area of benzene on the right hand side of the column, or on the right hand side of V104 as we are looking into the PNID. So he has marked that as well as node number 3, and he noticed that in that line he's got like not more than 2 considering pumps as well, which should have been considered on the left hand side as well. So there are not more than 2 equipments on each of these of these streams, and it can be counted, and rule number 2 is still valid. So considering rule number 1 and rule number 2 and the coaching I provided for Fred, I believe he's done a very good job marking all 3 nodes. And so like always that we have an exercise, I just wanted for you to work it out. What would be the problems if we extend the node further than 2 or 3 equipments? And if a node includes more than 2 or 3 equipment, what could possibly go wrong while we are doing the HAZOP? So put that as a part of your comments in the comment section, and we'll discuss about it all together. Thank you.